Hi everyone, this video is about control flow. That is the second part of the module 1. It includes expression evaluation, structured and unstructured flow, sequencing, selection, iteration, recursion and non-determinacy. Basic paradigms for control flow is sequencing, selection, iteration, procedural abstraction, recursion, concurrency, exception handling and speculation. So what do you mean by sequencing? It is the order of execution. Selection, it is also called alternation, generally in the form of if or case statements. Then iteration means loops. Recursion, expression is defined in terms of itself. Non-determinacy means this is the order of choice is deliberately left unspecified. Precedence and associativity. The C has 15 levels of precedence. It is too many to remember, and Pascal has 3 levels, due few for good semantics. Portet has 8, Ada has 6. This Ada puts and or at the same level. So this is the expression evaluations in different languages of this. So we can see the operator precedence levels in Fortran, Pascal, C and Ada is shown in this table. Next is expression evaluation. What do you mean by expression evaluation? It is the ordering of operand evaluation. Applications of arithmetic identifiers. Commutativity is assumed to be safe. Associativity is sometimes dangerous. If a plus b plus c works if a is equal to maximum of integer and b is equal to min int and c less than 0. Does not this type of cooperation can be useful though for code optimization. Another is short circuiting. Consider A less than B and B less than C. If A greater than is equal to B, there is no point evaluating whether B less than C because A less than B and B less than C is automatically false. So this type of expression is called what? Evaluation is called short circuiting. Okay, if first expression is false, there is no point of evaluating the remaining portions. So other similar situations are given if b not equal to 0 and a by b is equal to c and if pointer p and p tends to true. To be cautious, need to be sure that your second half is valid or else coder could miss a runtime error without proper testing. Variables as values versus variables as references. There are value-oriented languages, for example, C, Pascal, and Ada. The reference-oriented languages, such example of such languages is the most functional languages. For example, Lisp, Scheme, ML, Clue, Smalltalk. Algol 68 is halfway in between, Java deliberately in between. Most languages distinguish between expressions and statements. Okay, what is expressions? Expressions always produce a value and may or may not have a side effect. For example, in Python, B plus C. What is statements? Statements are executed solely for their side effects and return no useful value. Example in Python, mylist.sort. A construct has a side effect if it influences subsequent computation in some way. Expression-oriented versus statement-oriented languages. Expression-oriented languages are functional languages like Lisp, Scheme, ML, Algol 68. Then there is statement-oriented languages, that is most imperative languages. Then C halfway in between allows expression to appear instead of statement but not the reverse. This is orthogonality feature. What do you mean by orthogonality features? The features can be used in any combination. Okay, the features can be used in any combination. It is called what? Orthogonality features. Algol 68 is primarily example. Here everything in an expression. Then there is no separate notion of statements. Example, if begin, if B less than C, then D else E. A is equal to begin f of b g of c end. G of d is equal to 2 plus 3 end. Assignment. What do you mean by assignment? The statement executed for its side effect. Programming languages you have seen so far. Then assignment operators, handy shortcuts, avoid redundant work, perform side effects. Some languages allow multi-way assignment. For example, AB is equal to CD defines a tuple equivalent to A is equal to C, B is equal to D. Note that this can simplify things. AB is equal to BA, ABC is equal to food DEF allows a single return. C and assignments within expressions. Combining expressions with assignments can have unfortunate side effects depending on the language. Pathological example, C has no true Boolean type and allows assignments within expressions. It allows assignments within expressions. That is shown in the figure. What do you mean by side effect? Often discussed in the context of functions. A side effect is some permanent state change caused by the execution of function. Some noticeable effect or call other than return value. In a more general case, assignment statements provide the ultimate example of side effects. They change the value of a variable. Side effects are fundamental aspects of the whole von Neumann model of computation. In pure functional logic and data flow languages, there are no such changes. These languages are called single assignment languages. These languages are called what? Single assignment languages. Several languages outlaw side effects for functions. Easier to prove things about programs, closer to mathematical intuition, easier to optimize, easier to understand. But side effects can be nice, considerably grand. Side effects, what do you mean by side effect? You see the expression f minus f of b minus c star d. Okay. So if f of b may modify d, then the value of a minus f of b minus c star d will depend on whether the first subtraction or the multiplication is performed. Okay, this type of expressions is known as what we mean by side effect. Some compilers attempt to optimize code. Example, a is equal to b plus c, then d is equal to c plus e plus d. Arithmetic overflow can really become a problem here. Can be dependent on implementation and local setup. Sequencing specifies a linear ordering on statements. One statement follows another. Very imperative von Neumann. In assembly, the only way to jump around is to use branch statements. Early programming languages such as Fortran, even BASIC and C. Next is go-to statements. In 1968, Edgar Dijkstra wrote an article about the go-to statements. While hotly debated after this, go-tos have essentially disappeared from modern programming languages. This is the advantage of structured programming, a model which took off in the 1970s. So, structured programming, it emphasizes on top-down design and modelization of code, structured types. Getting rid of goto was actually fairly easy. Goto jump to end of current subroutine, use return instead. Goto to escape from the middle of a loop, use exit or break. Goto repeat sections of code, loops. Several settings are very useful for gotos. However, want to end a procedure loop early, the solution is now is break or continue. What about bookkeeping? We are breaking out of the code which might end a scope. Needs to call destructings, deallocate variables, etc. Adds overhead to stack control. Must be support for unwinding the stack. So biggest need for goto is another example exceptions. Goto was generally used as error handling to exit a section of code without continuing. Modern languages generally throw and catch exceptions instead. Adds overhead but allows more graceful recovery if a section of code is unable to fulfill its contract. Then next is sequencing. What do you mean by sequencing? It is the blocks of code are executed in a sequence. If the blocks of code are executed in a sequence, it is called what? Sequencing. Blocks are generally indicated by open and closing braces or similar construct. Interesting note, without side effects, as in Algol 68, blocks are essentially useless. The value is just the last return. In other languages such as Euclid and Turing, functions which return a value are not allowed to have side effect at all. The main advantage is they are idempotent. It means any function called have the same value no matter what it occurs. Clearly, this is not always observable, of course. Next is selection statement. It is introduced in Algol 68. Sequential if statements means if then else, if then else, if else. For example, in Lisp, you can see conditional C to E2 up to C and E and T E2. Then Fortran computed gotos, jump code for selection and logically controlled loops. No point in computing a Boolean value into a register then testing it. Instead of passing register containing Boolean out of expression as a synthesized attribute, we pass inherited attributes into expressions indicating where to jump to if true, whether to jump to is false. Jump is especially useful in the presence of short circuiting. If A greater than B and C greater than D or E less than or greater than F, then close, else close. This is the code generated without short circuiting in Pascal. This is the code generating with a short circuiting. Another is case statement. Case statement means case switch statement was introduced in algol W to simplify certain if-else expressions. Useful when comparing the same integer to a large variety of possibilities. For example, I is equal to complex expression if I is equal to 1, else if into 7. In case you are given 1, 2, 2 to 7, like that. While it looks nicer, principal reason is called optimization. Instead of complex branching, just loads possible destination into a simple array. Additional implementation of cases, if set of labels is large and sparse, like 1, 2 to 7, 8 to 100, like that, a set of labels is given, then you can make it more space efficient using hash tables or some other data structure. This is iteration. What do you mean by iteration? It is the ability to perform some set of operations repeatedly. So loops, expressions, loops, recursion. Can think of iteration as the only way a function won't run in linear time. In real science, this is the most powerful component of programming. In general, loops are more common in imperative languages, while recursion is more common in functional languages. Example is enumeration controlled loop originated in Fortran, in Pascal or Fortran style for loops. For example, enumeration control loop is given do I is equal to 1, 10, 2 into example. Change it to standard for loops later. Example in modular 2 it is expressed as for first to last by step do end. Then iteration for generation. At its heart, none of these initial loops allow anything other than enumeration or represent preset fixed number of values. This allows very efficient code generation. This can sometimes be optimized if the number of iterations can be pre-computed, although need to be careful for overflow. Basically, pre-compute total count and subtract 1 each time until we hit 0, often used in early Fortran compilers. Using iteration counts like this does require that we are able to pre-compute. This type of prediction is always possible in Fortran or ADA. There are some issues in iterations. The issues are given is going to say they can control enter or leave the loop other than through enumeration mechanism. What happens if the loop body alters variable used to compute end of loop condition? What happens if the loop modifies the index variable itself? Can the program read the index after the loop has been completed? If so, what is its value? These are some issues in iteration. There are iteration loops in C. The for loop in C is called a combination loop. It allows one to use more complex structures in the for loop. Essentially, for loops are almost another variant of while loop with more complex updates and true-false evaluations each time. Operator overloading, such as operator plus plus combined with iteratives, actually allow highly non-enumerative for loops. Other languages, Ruby, Python, C++, require any container to provide an iterator that enumerates items in that class. This is extremely high level and relatively new. Another is logically controlled loops. While loops are different than the standard Fortran style for loops, since no set number of enumerations is predefined. These are inherently strong, closer to if statements in some ways, but with repetition built in also. The downside is much more difficult to code properly and more difficult to debug. Code optimization is also harder. None of the for loop tricks will work. Another is recursion. Is equally powerful to iteration, mechanical transformation back and forth, often more intuitive, name implementation less efficient, no special syntax required, fundamental to functional languages like Scheme. Is recursion slower? Many criticize that recursion is slower and less efficient than iteration. This is a bit inaccurate. It is naively written iteration is probably more efficient than naively written recursion. In particular, if the recursion is tailed recursion, the execution on the stack for the recursive call will occupy the exact same plot as the previous method. What do you mean by tailed recursion? It is asked in previous question papers. So, tailed recursion means no computation follows recursive call. If a recursive call is there and there no computation is allowed after the recursive call. For example, in GCD, int A, int B. Okay, if A is equal to B, return A. If else, if A greater than B, return GCD is A minus B, B. Else return GCD A, B minus A. So no computation is after the recursive call. Such type of functions are called tailed recursive functions. A good compiler will translate this into machine code that runs in place, essentially sequencing to the start of the function with new AB values. Even if not initially, tailed recursive simple transforms can often produce tailed recursive code. It's known as continuation passing. Then next is order of evaluation. Generally, we assume that arguments are evaluated before passing to a subroutine in applicative order of evaluations. Not always the case. Lazy evaluation or normal order evaluation pass unevaluated arguments to functions and value is only computed if and when it is necessary. What do you mean by applicative order? This is preferably for clarity and efficiency, but sometimes normal order can lead to faster code or code that would give us many runtime errors. So this is all about this video about control flow. I will come with the next video. Till then, bye.